So, just a quick recap as to what we were doing yesterday. We are considering the space spanned by these people x n minus p, okay. When I mean let me make it more general. We had actually the basic space was this. You can identify this actually. Span of this. In one case, we had x n in the beginning. In another case, we had x n minus p minus 1 towards the right. Okay. If we called it W 1 p. Okay, we call it W 1 p. This span. Then very quickly we had these definitions. E p f n was nothing but project x n on the space spanned by this and take the error. P 1 p perpendicular x n sigma p f square n goes, because these are variants of this. Variance is what after all? X n minus a linear combination of this. That is the projection error, and those combiner coefficients are independent of n because of stationarity we know. If you do the variance of that, again because of stationarity, only the correlation values come up from which n disappears. So, that is why this variance is independent of n. It is nothing but norm square of this quantity, this norm square of E f n, E p f n, that is equivalent to norm square of E p f n, right. Norm square means variance, expected value of mod square, because that is our definition of inner product. Inner probability x and y is two random values x and y are given E of x y star correlation, and therefore norm means variance E of x into x star. Okay. Similarly, for the backward prediction we had E p what? E p b n. That time x n minus p was projected on the space. This was not the space that time. This I am considering only for the forward case. For the backward case, your space starts from what? I mean, it is a span of which elements? X n minus 1 up to x n minus p plus 1. Those are the p future terms if you are standing at n minus pth point. Is it n minus pth point, the p future terms. So, that means what? N minus p, x n minus p needs to be projected. Okay. And on what? 0 to p minus 1. Are you following this? N minus p, you are standing there because this backward prediction is standing there, pth order. So, p future terms. What are those future terms? X n minus 0, x n minus 1 dot 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 x n minus p plus 1. So, starts at 0 delay up to p minus 1 in delay. Okay. This span space corresponding projection, the corresponding error, and again notation was same thing. Okay. Then I found out an update relation, update recursion. Actually, it is called order update recursion, because update was in terms of p. You gave me E p f n and E p b n. Question is get me E p plus 1 f n and E p plus 1 b n. So, I am updating it in p. P is the order. So, it is called order updating. Finding out the same things for higher order. That means x n was to be projected on the space spanned by not just x n minus 1 to x n minus p, one more element. What I did, that element is x n minus p minus 1. So, net space is what? If you take x n minus p minus 1, project it orthogonally on this, take the error, then this net subspace will be what? Direct sum of or orthogonal sum of span of this and that error, space spanned by that error term. Okay. And then I projected x n on this, with projection on this part, projection on the other part, then take the error, and we got an expression for E p plus 1 f, E p plus 1 f n. Similarly, we did for E p plus 1 b n. Just for your sake, I am writing the recursion, we draw the lattice stage also. The recursions were like this. These are all there, delta p by sigma p b square, I think. I will tell you, I will again rewrite what is delta p, though you all know what it is. E p b n minus 1 and minus delta p star where delta P was either, I mean, the EPFN and EPV n minus 1, inner product between the two, that is the variance, sorry, the correlation. But the correlation is independent of n again because of stationarity, because this error is nothing but original xn minus the projection coefficients are independent of n, this also xn minus p minus 1 minus the projection, and you multiply those two expressions, all products of some xn minus k into xn minus l, that kind of thing will come, n will disappear because of stationarity, you get a next term in terms of correlation of the process, but independent of n, we call it delta p. It is called Parcours coefficient. In one case we have delta p, another case delta p star. With denominator, these two quantities are real, and in our case non-negative, because there is no linear relation between xn, I mean all the samples of xn. So, no xn, no sample remains in the space spanned by the rest, which means the corresponding orthogonal projection error cannot have a zero variance, cannot have a zero norm. That is why division by 0 does not occur. Have you seen this? Division by 0 never occurs because no sample of xn, no sample is remaining in the space spanned by the rest. That is the projection error has got a non-zero, there is a strictly positive norm square. That is why these things do not give rise to division by 0, but they are real, positive and real. Okay. So far so good. I said that time that I will start this business assuming that p is greater than equal to 1. So that even when in extreme case p equal to 1, you consider now p equal to 1, w 1 comma 1 was span of this, xn was projected on this, the error was found, that error you start with, then you want to go for one order up. So, you introduce xn minus 2, the same process. But how about the case p equal to 0? That is, you are starting with the case where you are starting, I mean, to go for the projection on the space spanned by these two, you are starting with what? E1 Pn, but who gives you this? Again, this also has to be obtained recursively, isn't it? EP plus 1, sorry, EP plus 1 Fn is obtained recursively from EP Fn and so on and so forth. You start with E1 Fn, then you go to E2 Fn, so on and so forth, but who will give you E1 Fn? To get E1 Fn, you have to start at E0 Fn. E0 Fn means what? That is what we do not know. E0 Fn means xn projected on nothing. When p equal to 1, there is something. P cannot be less than 1. So, xn projected on nothing and then the error. That nothing and error, these are all very qualitative vague terms, isn't it? So, we have to see what they are. We have to really define separately what is, I mean, E0 Fn, what is E0 B n or n minus 1. This we have to define separately. So, using them I can find out E1 Fn, E1 Bn. E0 Bn or E0 Bn minus 1 you define using these two. I have to find out E1 Fn, E1 Bn, but I have to define them. You understand the problem, na? Because I started at p equal to 1 and then I can go for p equal to 2, p equal to 3, p equal to 4 like that. But to get p equal to 1 case recursively means I have to get the case for p equal to 0 also, isn't it? But p equal to 0 case has got actually no mathematical meaning, because then there is no element. Yes? No. No. This is a set. This was a space. I have not considered space. It is a set. They span a space. Append one more element. Set again. It spans another space. But from the set, you are supposed eliminating one element another. You are left with this, and now you are saying no. I am not even taking that. You understand, na? You want to find out the projection error when xn is projected on the space spanned by this fellow only. That we call E1 Fn. Now, to get it recursively, you have to start at E0 Fn. E0 Fn means what? 0th order, there is no term, empty set, spanned by the space spanned by empty set and all that. There has no meaning actually in terms of the axioms that I gave, isn't it? That is why this is my way of training. Books write some qualitative things and all that, but that is mathematically invalid. That is what I am saying. If you have to be true to mathematics, you have to consider those cases separately. You have to give separate definitions. Now, this we know. Or you can also draw the structure here quickly. Kp I gave, no, I forget the notations, and the other one I gave, yeah, in the previous year's class I called it Kpf and Kpb, forward prediction, backward prediction. Anyway, Kp, Kb star is fine. One is the conjugate of the other very soon. This is Kp prime, right? And here you get your Ep. Okay, you go on cascading it till you have E1 Fn, E1 Bn. Before that, what happens? That you have my problem is, isn't it? So now instead of doing all this by vector space method, let me work out directly. After all, what is E1 Fn? Means you have to take Xn, project it on the space spanned by Xn minus 1, sorry, Xn minus 1, E1 Fn after all. Okay, and take the error, that is Xn minus when I use these notations, I treat them as vectors. When I bring in E operator and all that, then they are back to their physical form, that is random variables. Okay. Please understand there is a slight mathematical thing actually. I mean this what is incorrectness in notation, because I am repeating the same Xn thing in the vector space form also. I should put a bar underscore or something to indicate that I am treating them as vectors, but I suppose by now you are pretty conversant. So when I am dealing them writing this using this notation, I am basically meaning inner product of vectors. I am looking at them as vector. Finally, when I replace by E of something, then their actual physical form will be brought in operation. Okay, these times, and now we bring in those forms. What is this? Okay, I can even keep it like this. But physically I know what it is. It is expected value of Xn, Xn minus 1 star. That is correlation with lag 1. And what is this? This is nothing but variance, independent of n. So that is n or n minus 1 does not matter. Okay. And what is E1 Bn directly? Xn minus 1 is to be projected on Xn, and error has to be taken, right? Xn minus 1 has to be projected on Xn, n minus 1 that has to be projected on Xn, one term, now only one future term if you are standing at n minus 1, Xn, and the error now you compare the two, this with this and this with this. You can say I can define, if P 0 you put, okay, I define now, I say I am mathematically correct, I define E 0 Fn as X, say everything will fall in place, you just see, and according to me this is how it should be taught. Some books have the very vague way of saying, I am projecting in space span by empty, that is nothing, so I take the error, I get back the same thing. This is nonsense, this is has no meaning, isn't it? Space spanned by an empty set, what is the meaning of that mathematically? No, space spanned by empty set means what? There is no definition. Did I give you that? Was it part of the axioms? It is not. Only some physical vague argument, that okay, I space on project on nothing and therefore I get back everything. This is these are books, right, but this has to be this way. That you can just see I am defining, that I am really defining now. Looking at this, I have to bring them in the same fold of recursion. What I am doing, this I compute separately. I am to prepare in the same recursive formula, by the same recursive formula. That means Xn, if you put Xn equal to Fn and as again Xn, E0 Bn Xn, so that means this is E0 Bn minus 1. I am saying E0 Bn also Xn. That means E0 Bn minus 1 coming. Now delta P, look at this, it should be Epfn Ebn minus 1. You see, E0 Fn, E0 Bn minus 1. All these things are coming, right? Sigma P B square. That means norm square of what? E0 B n minus 1. That is Xn minus 1 only. Isn't it? Are you seeing this now? That That means, in those recursions I can now start at p equal to 0 and go ahead, and I will give the initial condition like this, and two more conditions, the corresponding variances also. Though I have not done anything for variance as far as recursive way of doing things is concerned, I have only done for this sequences, these signals, not for variances. Variances are independent of. Nevertheless, sigma 0 f square is the variance of this guy, and sigma 0 b square is the variance of again this guy. Both are same. So, at 0th stage both are same. That is the reason why they are same for any order. Stationarity plus that, his logic was missing that at the 0th stage both are same. This is nothing but sigma x square. Okay. So, now I have got this perfect lattice structure. So, what is this lattice? This kind of stages, you see, initially you have got x n, this is one stage, you know the values. Now, I am not writing the values here. It will come. You can put the corresponding values with the order. P will be 0 in this case and all that, is delta 0 and all those. Dot dot dot. In general, this is a stage. Typical lattice structure. Huh? So, you understand this order recursive structure, it is recursive in order. If you have to carry out, if you have to find out projection for one extra order, you do not have to destroy this previous part, you just add one more stage. Each section is called stage, one stage. Structurally, from circuit point of view, they are identical sections. Values of the multipliers and all are different, but structurally they are same. So, you just go on cascading more and more structure this thing. So, it is very easy for, very nice for VLSI. Just you design the mask for this and go on repeating it. You understand? No, this is order recursive, very nice for VLSI. It is absolutely fantastic for VLSI relation. This one stage is to be repeated. Structurally, same thing you are repeating. Multiplier values will be different, these values. So, remember, you can draw this structure and all this, provided you know the coefficients, isn't it? This is the thing which works in real time, gives you all this EPFN, EPA, BN and all those things in real time as function of n. This is the filter, that is filter, it gives you all those things, but provided you know the coefficients. But coefficients depend on what? Those inner product, there is correlation between the respective projection errors and the corresponding variances. The entire lattice is defined by this coefficient, isn't it? Z inverse is there, is a constant thing, plus. So, what determines the lattice? Only the values of the coefficients. And what are the coefficients? The delta p's by and the two variances, right. So, then we should then try to develop computational ways, but what will be given? You will be given only this random process and its not random process, but its correlation. I will be giving you the autocorrelation stationary process 0 mean say and all its autocorrelation values for sufficient lag, 0 lag, 1 lag, 2 lag, sufficient number of lags will be given to you. You will be asked to construct this filter, that is develop these multipliers with proper values. Once you have that, you start filtering xn through that, you will get those projection errors as theory suggests. But how will you compute them? Because then that means you have to compute them. How can you compute them smartly? Because you are not giving these values, you are giving only correlation values, whereas what you are getting here in these multiplier coefficients are these inner products of errors and the corresponding norm square of the errors. Okay. So, this is the next step. That is a non real time operation, mind you. This is only a computation back room, offline computation, giving a set of correlation value, how to generate the synthesize the lattice filter. There is only that computation. Once you synthesize it, implement the filter with those coefficients and work for real time. Say process the same action, you will get those corresponding projection errors accurately. Still we do not know what is the utility of all this will slowly emerge. You will see what all things it can do. You know, it is one of the most beautiful things that have come up in adaptive signal processing, lattice. And then it is key to speech processing, most of the speech work. Anyway, so let us target these fellows, the two variances, because I told you, and there was a kind of, you know, I mean, a difference of opinion with some of you as to how to prove that these two are same. That for the backward and the forward, yes, the two norms are same. So let us tackle that first, then we will come to this delta fellows. So, sigma, again I will say, I will show that I can have ordered recursion for those variances also. That is, suppose you give me sigma p f square and sigma p b square for some order p, I can get, and of course delta p, then I can get do same things for order p plus 1 also. Okay, people tried and found out, and this is my claim, and I am making a claim, and I will just show it is doable. So, sigma p plus 1 f square I want to find out. Now, what is that? That means p forward prediction x n minus 1 up to x n minus p minus 1, they are spanning a space, project on that, take the error, project whom, project the current guy, take the norm square, and now have to bring in some beautiful linear algebra, the kind of thing that you are already used to. Inner norm square means inner product with itself. But I am sure you will permit me to drop this from one of the two. I drop this here, I keep it x n, it is okay. I have done it many times. This is what? Forward prediction error for p plus 1th order. For this I already know the recursion, isn't it? That lattice recursion. So, I put that here. This is E p f n minus the delta p thing. Delta p we know, I am not defining it again. You remember that this recursion I am bringing back here. E p plus 1 f n is equal to this. We know what is delta p and all. So, I am not defining it. This is n. Comma x n. And now, inner product with this and inner product with the rest. First one again E p f n comma x n minus something, I am coming to that, minus what? Delta p and delta p by sigma p b square, they can come out this part with this now, since inner product these coefficients are coming in the first coordinate, they do not get conjugated, they just simply come out as it is. So, delta p by sigma p b square okay. Now, what is this quantity? This is p 1 p, and you do not mind if I repeat this here, p 1 p perpendicular on this. I told you I can always bring that back here. After all, what is the physically what was happening? Just to remind you, x n can be written as what? As a summation of two components. One, projection on the space spanned by x n minus 1 to x n minus p, and the error. That projection part is orthogonal to this fellow. So, that part will be 0. So, only that error part will be there. See, that I did many times. Again, by for your sake, so that you do not forget it, I am reminding. When I am saying just I can take this operator and repeat it here, physically what does it mean? X n I am writing as a summation of two components, one the projection and the projection error. Projection space is same, spanned by x n minus 1 to x n minus p, but the projection part and this orthogonal, they are cancelling the inner product. So, again the error part will be there, isn't it? And if I bring it here, p 1 p perpendicular x n, this will be this same as this. This is p 1 p perpendicular x n. This fellow will be brought in here. So, the same thing, P1 P perpendicular xn. That means norm square of norm square of this fellow. Are you understanding this? I don't know how many, all are understanding or not. Same thing is repeating here now. P1 P perpendicular xn this fellow. I apply the operator here. The 2% are same. So norm square means but for order p. So sigma p f square. See, it's becoming recursive minus here again. What is this guy? P please see, it's little trickier than that. For backward prediction is always EPB n minus 1. Again, in case you are confused, what is the at what index we will be standing? N minus 1 minus p, and look at p future terms. You call n minus 1 as n prime, like yesterday. Call n minus 1 as n prime. So n minus 1 minus n prime minus p is your index. From that you are looking at p future ones. So what are the terms? N prime minus 1, n prime minus 2, dot 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 n prime minus p plus 1. They are spanning a space on which you are projecting. Now replace n prime by n minus 1. Immediately get this operator. Are you understanding this? This fellow, what was this fellow actually? Either you remember it always, or what was this guy? This guy is, my claim is, if you take this and you have got an extra component coming here, xn minus p minus 1. You project this on this span, on the span of this, and take the error. That fellow is this, isn't it? Because you can always call n minus 1 as n prime. So n prime minus p, n prime is the current index. N prime minus p, you are standing at looking at p future terms. So n prime minus 1, n prime minus 2, n prime minus p plus 1. Then if you project, by definition that is the backward projection error, pth order for index n prime, that is what it is, but index n prime is n minus 1. So this is this projection. I have given this definition time and again, but in case you get confused, I am just repeating so that you get pretty used to it. And now this I can repeat on this. I can bring this P1 P perpendicular here. This operator I can repeat by the same logic. Now don't ask me to repeat the logic again. 2 minutes back P1 P perpendicular on this means what? Forward prediction. Right. So delta P, and this becomes what? Inner product between EPB n minus 1, EPFN, which is delta P star. Delta P was inner product between this and this. Now it has become reverse, which is nothing but so you see how nicely recursive it is. If you know these two guys and this guy, for that lattice stage you know this guy, but then I have to find out same for B also. After all, you need this fellow also, you need this fellow also, you need this fellow also. Then only you can get sigma p plus 1 f square, but then I must get this fellow also, this fellow also for p plus 1th order, isn't it? Otherwise, so I cannot proceed recursively. So for this also in the same way we can find out. So quickly I go through that. Absolutely similar way, just the spaces will be slightly different, as you know. So let's carry that out. That is your norm square of what? Sigma p plus 1 b square. That means x n minus p minus 1. That is what you are standing, looking at p future, p plus 1 future terms. P plus 1 means starting at current 1 x n minus 1 dot 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 up to x n minus p, then it becomes p plus 1, right. So that means p 0 okay. This means I will now jump over some steps. This means inner product with itself, but from one of them I will remove this operator. Clear it? From one of them I will remove this operator. Say, so let it be like this. And this is what? This is backward, your backward, it's a backward prediction error, x n minus p minus 1, p plus 1th order backward prediction error for index n. Index n is the current index, this is p plus 1, that is where this is actually e p plus 1 b n. N minus p minus 1 is the index, that where you are standing, looking at p plus 1 future terms, isn't it? This is this, and I know for its recursive formula. Recursive formula I know in the lattice computation, simply replace that. That was e p b n minus 1 minus what? Delta p star, no? I had delta p star that time. Okay. I just replacing this by that lattice recursion, lower branch. I had delta p star for there, and then this two inner product. Same operation. What is this? Again, write. After some time, it will become very mechanical. Similar kind of steps I am doing again and again. E p b n minus 1. What was that? P 0 to pth order. Sorry. P 1 2. Very good. N minus 1 is the current index, n minus 1 minus p. From there, looking at p future fellows. Those p future fellows are x n minus 1, x n minus 2 up to x n minus p. That projection. And this fellow. So, I will again repeat this on this guy, and I get back this guy. These two are same. So, this part is simple. This is the backward prediction error for this, I mean the norm square for this fellow. Because of stationarity, this is simply sigma p b square. Okay. Norm square of this fellow, pth order. Here again, it is pretty simple. This is p 1 p perpendicular x n. So, this also I will make it p 1 p perpendicular. This I have already seen. What is this? This guy is. This is nothing but e p b n minus 1. So, this inner product becomes delta p. This is delta p. So, this is again mod delta p square. So, if it is backward, first term is backward, in the denominator forward. If it is forward, first term is forward, in the denominator backward, that way. Okay. Now, I can easily prove that both sigma p f square and sigma b square are same. It is very easily proved by induction. Suppose up to the order p it is true, up to the order p it is true that sigma p f square is equal to sigma b square. That is, suppose up to order p sigma p f square is sigma p b square. Then we already found out this formula. This we have already derived, just now we have derived. we have just not derived, and these two are same. So, you replace this by again this guy by this. So, this is same as what we got. Okay. The question is, in induction this is the major step, but you have to show that it is true for at least p equal to 0 or somebody. But for p equal to 0 case, both 0th order forward and backward prediction errors were same as x n, isn't it? So, corresponding norm square was or variance was simply variance of x n. So, it was true at least for p equal to 0. For p equal to 0, a square is E, which is also same as sigma p b square, sorry, this, because E p E 0 b n was x n again. So, this is true for p equal to 0, and therefore, it is true for all orders. Okay. So, henceforth, I will simply write sigma p square in the denominator, neither sigma p f square nor sigma p b square. So, my notation will be sigma p f square and sigma p b square will go to just sigma p square. There is slight inconsistency in notation, because when I come to x n, its variance I write as sigma x square, isn't it? So, as though quantities in the same domain, they are not. Here p means order, here x means signal. So, if you please permit me to do this, okay, because do not p to be a signal and x to be, do not try to see equivalence between the two. Here it only means, because we will not be mixing up, very rarely will that question come up as to the variance of x n and all that. Okay. So, our sigma p square means this. Okay. Then comes another beautiful property, that is, each of the reflection coefficients has magnitude less than 1. Reflection coefficients are what? Delta p by sigma p square and delta p star by sigma p square. Obviously, both have same magnitude, you understand now. Denominator is same, just now proved. Numerator is delta p or delta p star. So, magnitude of each reflection coefficient in the both the branches in each lattice stage, they are same, isn't it? Numerator conjugate of each other, denominator same. Now, I will show that they are not only same, they are same of course, but they are all having magnitude less than 1. How many of you know Cauchy-Schwarz inequality? Have you heard of Cauchy-Schwarz inequality? How many? And how is it proved in books? Just tell, you do not have to reproduce the entire proof, just tell me how it is proved usually.
X minus gy.
They do all those things and square up and all those things, isn't it? But I will prove it, you see the proof for today and then never forget it in life, because this is what Cauchy-Schwarz inequality is. The proof is in vector space.
And this proof is not anywhere.
I do not know. No, this proof is in books, maths books, linear algebra books, definitely. I have not constructed the proof. I won't claim that, no way. But this is the actual history of genesis of Cauchy-Schwarz inequality. It says that suppose x and y are two vectors. Even real numbers can be treated as vectors in a vector space of real numbers, isn't it? That way. So, this extends to even numbers also. You understand what I said just now? Even real numbers can be treated, because two real number added is another real number. So, closed standard addition. Real number into the scalar times real number, scalar is a real itself, is again another real number. So, set of real number is a vector space over itself. So, whatever I prove in the context of using vector space, they are all valid there. But in the case of real numbers, they are much more structured than this. They have got a distance, a lot of things, distance measures, many other things. Whereas these only abstract symbol, so very few degrees of variable, just two operations, one abstract plus, another abstract scalar multiplication, other things. Real numbers you can just play havoc with, anything you conceive of you can do. Okay. First it says Cauchy-Schwarz inequality. Yeah? Suppose x, y element of V where V is a vector space. Even it is true for infinite dimensional vector space also. What I am proving, I am not using even the finite dimensional nature of the vector space V, V over say C in general, or of course the C is required, C or R is part of C only. Real field is a part of C only. So, whatever I do for C, that is valid for R. But if you change the field into say binary field consists of two numbers 1 and 0, that also is a field, modulo 2 field, then this will not work. There is a problem. I have to define a more, then that's, I mean, high stuff mathematics. You have to define more generalized Cauchy-Schwarz for any arbitrary field and all that. That's mathematics. This says that if you take the inner product between them and take the mod, this is always less than equal to norm of this into norm of this. Sometimes books put a square on this and therefore square and square, which I am sticking to this form. Well, both are equivalent actually, because you are taking positive, mod means positive number only. So, if this is less than equal to this, obviously square also will be less than equal to, and vice versa. Okay. This says that this is always less than equal to, then equality holds if y is y equal to k x or x equal to say k y, some k prime y. That is simply because y equal to k x, you can always say that means x equal to 1 by k y, but if you take k to be 0, then I cannot write 1 by 0 times y. So, just to take care of that fact mathematically. So, this is how mathematicians work, na? I could always say if y equal to k x, equality holds, but I am adding this extra statement. Why? Mathematically y equal to k x means immediately I can say, okay, suppose I put k equal to 0, this is true. But does it mean x equal to then 1 by 0 y? That has no meaning. How to prove it? This is true means, or this is true means y and x, they are in the same space. Y in the space spanned by x, or x is in the space spanned by y. Okay. Suppose y is in the space spanned by x. Suppose y, there is this case, then only, isn't it? Obviously, in this case, if you really, that means y equal to some k x, you put that back here, equality will be, you can easily see. After all, what is norm y? Norm y means square root of, positive square root of inner product with itself. Norm square is inner product with itself, norm is positive square root of inner product with itself. And you replace y by k x, k go out k star, mod k square, x with itself, norm square of x, positive square root. So, you get mod k times, isn't it? Put that back here, mod k times mod x square. On the other hand, left hand side you put y equal to k x, k star goes out, mod k and x with itself, mod of that, x with itself, no need to put a mod on that, isn't it? Norm square. So, that is clearly satisfied. Understood or not? This is trivial. Now, suppose it is not. Bolo Joseph, you have some question? Now, suppose it is not. That is y does not belong to. For this case, equality holds we have seen. Now, suppose this is not, then we have to show that it is strictly less than. So, in this case, suppose y does not remain in span of x. That is, suppose span of x is this space, span of x this, y is here. I then project y on this. When you read Cauchy-Schwarz books, all this projection, unique, nothing is told because people don't, I mean, they don't expect people to know, but now you know all that. Suppose I project orthogonally on this. Since y is outside, this error or projection error vector will have norm greater than 0. Norm cannot be less than 0. If norm equal to 0 means, this is 0 means y itself is here, but that is contradiction because I said that y is outside the span of x. Logically, y is outside the span of x. That means, if you take the orthogonal projection, projection exists, it is unique. Take the error, that error is orthogonal to this span. Now, my claim is that error cannot be 0 vector, because if it is 0 vector, then y remains in the span of x only, which is contradiction, because I am considering the case where y is outside the span of x. Okay. So, that means it is error, and if it is not a 0 vector, its norm has to be greater than 0. Right. So, that means I am doing this way instead of greater than 0 on the right hand side, the norm square of this vector. What is the projection of y on x? Y inner product with x divided by norm square of x into x, and projection error is y minus that. Norm square, sorry, right. This is a projection, this is a original, this is the error, norm square of the error strictly greater than, because y is outside the span of x. Okay. This is just error now. This part is a projection, y with x divided by norm square of x into x, y minus that is the error norm square, that has to be greater than 0 because y is outside the span. Now, norm square means inner product with itself. So, imagine that I am writing inner product, this component, comma, again this same component. I am not writing that line, and then term wise inner product. So, how will that be? Y with itself one term, isn't it? Then this again put a comma, repeat the same thing. This term will come out x with y, this with itself now. So, this second term into first term, x with y, then again this with its right y with x, and this time this will come up with a conjugate, because it is in a second coordinate. I am not showing that extra line, following y with this from the first term y, from the second term this is the second coordinate. So, conjugate will come up. This is the problem. So, y x conjugate means it will become x y, denominator real, Of course, I should have said that x and y none of them is a 0 vector, because this is trivially obvious for 0 vector, because if there is a 0 vector, y is definitely k times 0 vector. I mean, if this is 0 vector, this is trivially obvious. I will take that considered later. I case later. None of them is a 0 vector. Otherwise, anybody could frown at this, that I am dividing by 0 and all that. None of them is a 0 vector. That I should have mentioned. For the 0 vector case, it is trivially obvious. You can just directly put and see. Inner product is 0 and norm of the 0 both sides. Norm of the 0 vector is 0. On the left hand side, inner product of one vector is 0. That also is 0. So, equality holds for 0 vectors. Okay. It becomes y comma x and then conjugate x comma y. This is in the second part. Y and the second, this term from the second. So, this comes out, that is why I made x y. And last one is plus this with itself. So, y x and x y, y x will come up and x y will come up by square again this square, okay, and x with itself. Okay. So, this is simple algebra here. This part is simple algebra. This term with itself. So, from the second thing this will get conjugated, it becomes x y. Denominator does not change because that is real. Denominator is norm x square repeats twice and x with itself. Now, you see one thing, consider this term and this term, they are same, because inner product with itself means norm x square. This cancels with this, y x x y by norm x square, y x x y by norm x square. So, you are left with this, and this is greater than 0. Now, the proof is obvious. Third term I have mixed out one term here. Third term here, there will be one more term I missed out. How did the third term come? This came out, no, how did the third come? Y comma x, y comma x, yes. Sorry, I only looked at the coefficient, but the inner product part I did not look at. This fellow in the first place, this fellow in the second place. So, this thing came out with conjugation, it becomes x y now, but inner product part with y and x I left out, sorry. So, then what do you get here? Norm of y square divided and mod square divided by norm of x square. This is greater than 0. So, proof is obvious now. Take this guy on the left hand side and you see the proof is done, na? Okay. Now, look at quickly our terms was delta p by sigma p square. Okay. Delta p, it is mod, I am interested. What is delta p? Delta p was E p f n E p b n minus 1. And what is this? Norm square of E p b n or n minus 1 does not matter, right. I am interested in finding the mod of this. Mod of this means this only, because denominator is already real, no point in real and positive, no point in taking mod and all that. Okay. Now, I apply Cauchy-Schwarz. Since I am assuming, since there is no linear relation, you can see yourself, this is not a multiple of this, they will not become, that is x n projected on this fellow the error and x n minus p projected on the same space and error, they will not be linearly related in general. So, in that case still I am putting less than equal to, actually it is strictly less than, because that will never happen, that x n projected on the past and the error and then x n minus p projected on the future and the error, they become one become the multiple of the other. It's not happening in our case, because there is no linear relation actually linking the samples or linking the projection errors and all that. Okay. But even otherwise this is always true, less than equal to. And so, this is what this norm is by Cauchy-Schwarz. And these two norms are same. These two norms are same. We have seen these two norms are same, isn't it? These two same. We have proved it. So, the denominator both are same now. So, equal to 1. Remember this will be required, because I will be using autoregressive modeling. There will be a all pole filter, the filter will be stable because of this property. Its poles will lie within unit circle, it will be stable and causal because of this property of the reflection coefficients. Okay, that is all for today. Thank you.